Welcome to this VegaStream online tutorial. In this session we will introduce the concept of call representation, a feature which can be configured on all Vega gateways. And then we'll see how to configure the Vega appropriately to suit your own applications. Call representation is configured using dial plans, and it is assumed therefore that you already have a basic knowledge of configuring these. If you haven't, then before proceeding further, follow this link to the Getting Started with Dial Plans tutorial. You can then return to this presentation at a later time. So just what is call representation? In the event that a call is not successful in reaching the destination which you have specified in your dial plan, call representation allows the Vega to route the same call to an alternative interface or proxy. So in the instance that a carrier or ITSP is unavailable, or that the path to that destination interface is faulty or busy, the call is given another chance to succeed. Furthermore, the user remains unaware that any diverse routing is taking place and his call is completed just as expected. So how do we configure the Vega to perform this for us? Well, there are two methods, and the correct choice mainly depends upon whether the telephone number, referred to in the destination element of the dial plan, needs to be modified at all in order for the new carrier to route the call. If the number doesn't require any alteration, then we can use the Vega Call Presentation Groups method to configure the function. On the other hand, if the new carrier does require that the telephone number be modified, then we must use the Planner Groups method to configure the function. Let's look at a typical case example of where these methods would be used. Here we can see a typical scenario whereby a Vega has been installed as a trunking gateway to a PBX. In this case, the PBX is connected to the first three ISDN2 basic rate interface ports on the Vega. There is a connection to the ITSP via the LAN interface on the Vega. The fourth BRI port on the Vega is connected to the PSTN for receiving inbound calls which are passed by the Vega and onto the PBX. Also, this connection can be used for outbound emergency and local calls, which are often not suitable for routing to an ITSP. And so dial plans have been created to route the majority of the calls to the ITSP using voice over IP. But as we can see, in the instance that the route to the ITSP is not available, the Vega has been configured to dynamically route calls to the PSTN instead, using the call representation feature. Often when routing calls to different service providers, it is necessary to present the telephone number in differing formats, so we must use the Planner Groups method to configure for call representation. Additionally, for our example case scenario to function correctly, call representation must also be configured to provide for inbound calls to the PBX as well. Let's consider that a call arrives either from the PSTN or the ITSP. The Vega's dial plans are configured to route this call to the first of the three BRI ports, which are connected to the PBX. But what if the first interface is already busy with other calls, or is faulty even? Again, the Vega must be configured to represent the same call to the next interface. And if the call is still unsuccessful, maybe because the second interface is also busy, then it should be presented to the third interface. Unlike the previous case, the telephone number does not usually require modification when providing this function, which is often referred to as auxiliary line working by service providers. Therefore, we can use the Call Presentation Groups method to configure call presentation. The next issue to consider is under what conditions should representation of calls occur. You may already be aware that whenever a call clears down or is rejected, a reason is provided in the signaling messages. These take the form of industry standard Q850 clear down calls codes, and the Vega may act upon these when deciding whether to initiate call representation. A document relating to this is available from the VegaStream technical portal, and selecting the Technical Documentation tab within any product area. Scroll down until you see the Q850 Clear Down Calls Code document. This document lists all of the codes, and against each of these we have indicated the likely reason for receiving the code. You will notice, for instance, that 16 is normal call clearing and is therefore desirable. But some of the codes which you are likely to receive for our example case scenarios are number 3, no route to destination, number 17, user busy, number 38 network out of order, and number 41 temporary failure. So now we are going to see how to configure the Vega using each of the two methods. Firstly, by using the call presentation groups method. Remember that we use this method when there is no modification required to the telephone number in the destination of the dial plan. When the first call fails, the Vega will receive a Q850 calls code, and if it recognizes this in its list, it will present the call to the next interface which you have specified. Let's see how to configure this. From the web browser's main menu, select the Dial Plan tab. You will note that I've already created 3 profiles for each of the 3 possible call flows arriving at the Vega for our example case study. These are calls arriving from the PSTN, calls arriving from the ITSP, and calls arriving from the PBX. So let's start by configuring the dial plans for those arriving from external callers and which are destined for the PBX. Therefore, as there's no modification to the telephone number required, we are going to be using call presentation groups for these 2 profiles. We'll start with the PSTN. So we click to modify the dial plans contained within this first profile. We're going to modify the first plan. We give the plan a name so that when someone reviews it at a later date, they can easily identify which call types it is applicable to. I'll call it Calls to PBX. The source is used to specify which interface the call is arriving upon. Remember that in this profile we are dealing with calls from the 4th BRI port. In the Tell field, we will insert a wildcard to deal with any telephone numbers arriving. The destination is where we specify the interface for where the call should be routed. We would usually refer to the physical interface. However, when dealing with call representation, we need to insert a virtual interface ID, and you will see why very shortly. We recommend that virtual interface IDs start from 1001 and work upwards, depending on how many of these you need to create in your dial plans. Because the telephone number doesn't need to be altered, we are going to pass the number received in the source. Now we submit that information and return to the main dial plan profile page. And now we set up for the same routing for calls arriving from the ITSP in profile 2. The only difference is that in this profile the call is arriving from the SIP interface. Again, we submit and return to the main dial plan profiles page when we're finished. And now we select the Call Presentations Group tab. We'll modify the first plan and give it a name which explains the function of the rule. Let's call it Auxiliary Trunks to PBX. And now we refer to the virtual interface ID 1001, which you'll recall we specified in the dial plan destination field. And now in the destinations area, we are going to configure the actual physical interface IDs which belong to this group. We must insert these in strict order, because in our example scenario we want calls to be sent firstly to the BRI interface. In the event that calls fail to this destination, we should specify the second, and then the 3rd BRI port. You will notice that we use the pipe symbol to separate these. On UK keyboards the pipe is found adjacent to the letter Z. Also we can choose in what order the physical port should be selected from list. First to last, which is linear up, or round robin, which has the effect of distributing calls to each interface in turn, or simply in a random format. We'll select linear up because for auxiliary working we always want the interfaces to be selected in the order that we have specified in the destinations below. In the cause code area, we specify the clear down cause codes as being the circumstances under which this rule should be applied. If the Vega receives one of these, then it will look to this rule and represent the call to the next physical interface which we have specified. We'll insert the codes for busy and if the interface is faulty, so that the call can be presented to the next interface. Note that the codes are separated with a comma. Lastly, we enable the rule by checking the box, and when we're finished, we submit the information and apply it to the Vega.